Hey guys, this is Bruce. Welcome to Convo Courses Podcast. Before we get started, I want to let you know that we've got a login.convocourses.com. We can join our group and talk to us on a daily basis. You also have access to learning modules that are some are paid, some are free. And recently, I have one called the AWS Cloud Practitioner Project One that walks you through an actual project that I did to learn AWS and to earn the AWS CCP, a fundamental cloud curriculum. After you get done with this, you'll be able to put this stuff on your resume listed as a legitimate project that you used. Also, I want to let you know that I use certain sites and resources to learn the fundamentals of AWS. One of them was learning by doing on brilliant.org. This is not sponsorship. This is what I actually used to learn some of the fundamentals of AWS. Of you could probably learn some cloud stuff, but AI is what I use this for. And it was very, very helpful to learn how it works. Another place I used was a Udemy. I didn't get the certification, but the curriculum was enough for me to learn what I needed to know. Another resource you'll hear me mention is the OWASP 10 top 10 large language module threats and vulnerabilities. And another place you could use, not to get in the certification, but just learning the curriculum and the fundamentals of AI, is Google AI Essentials. It's very, very basic, but it's going to show you what you need to know for the entry level AI stuff, which is what I'm going to be talking about here today. All right, guys, let's get into this. Recently, I started using Claude, um, having graduated from OpenAI and using Gemini as like a daily driver, but Claude is on another level. So it's more mature. The answers are clearer. Um, it's just different. With coding, it's different. Complex issues with writing, it's not even close. Like it's just way better than any other model right now. And it's no wonder that two of the most powerful organizations in the world right now are doing everything they can to try to control the IP for this product. You got the US government trying to coerce and bully them to go against their principles. The company Anthropic, they blacklisted Anthropic um, because they refused the Pentagon's demands. The Pentagon wanted them to allow the use of mass surveillance. They wanted to force them to allow them to use mass for surveillance using the AI. Um, and then they also wanted them to allow AI to order kill commands, like it would be able to just kill humans without any kind of human in the loop, any kind of human in the kill chain. It would just be able to. That's one of the principles Anthropic is against. Those two things, and everything else you can do whatever you want, but those two things, they're like, nope, you can't use our intellectual property for those two things, right? And really, I think this whole thing is just, it's just posturing. It's just a political stunt because the government's just going to do what they want with it anyway. They'll just reverse engineer it or whatever they got to do. They'll steal it, whatever they got to do. So all this stuff in the news is kind of just, I think, it's just a way for them to not lose face because it's publicly out there. So I think they'll just steal it or whatever. Speaking of stealing, you got the Chinese recently attempting to distill or basically pull all the data that they can to find out how Anthropic works by making thousands of fake accounts and using prompts to try to figure out what is the weights behind how Anthropic is doing what they're doing. So you got two the two most powerful organizations on planet Earth trying to use Anthropic for their own desires. and and now that I'm using it, I can see why. Um, and I bring all this up to frame what I want to talk about today, which is my journey into AI security. A couple of years ago, I started off um, going into cloud, and I mean, I'd done some cloud before, but not. I wanted to go deeper into it and be more technical. So about 2 years ago, 2024, now I started going into cloud. I kind of did the same thing I'm doing now, which is dip my toe in it, start learning the fundamentals, and go from there, step by step. And it paid off. Now I'm doing cloud positions. You know, I'm in that space now, feel comfortable with it, and going a little bit deeper into it. And now I know how important it is for me to do the same thing with AI because it's not going to go away. There's a lot of questions around it, right? There's obviously, like what there's a lot of talk about it taking all the jobs and everything. And I would present this to you. What's if that happens, what happens to the economy? Because we can't be capitalism anymore. I mean, because who's going to buy stuff? If nobody has jobs, you know, if you have a super high um, unemployment rate and nobody's buying anything, how are we going to continue with this economy? I mean, there's a lot of questions behind all of this. Um, I know this for sure. I don't know where all this is going, but this I know for sure. If I'm gonna stay in this space, IT, cybersecurity, cloud, whatever, right? I'm gonna have to not just learn AI, but I'm gonna have to find a niche, and then I'm gonna have to master it. And for me, being in cybersecurity for so long, the best way to position myself in this is to do AI governance or AI security operations. I don't think that that's going to go away. Um, Maybe it will be reduced. I don't or modified or changed, or I'm sure it'll evolve in some way. But I I think that there's always going to have to be someone there behind the scenes, a person to figure out how to help to align or control or even protect um, the AI and the data that in the data sets that those AIs are processing. So I saw a glimpse of this, just a tiny glimpse. I talked a little bit about this last week. And this last time of me trying to get jobs, uh, I was surprised. A lot of jobs were looking for somebody who knew AI, and I was just like, "Wow, it's already happening! It's already happening." I thought I had some time, and I don't. We don't have time. Like we have to learn immediately. Everything we can. Even if you're learning fundamentals of IT, you should integrate some AI as much as you can. If you're going into cloud, integrate AI. There's nothing. There's no, especially in IT, like any kind of field in IT. There's no field. There's no category where you shouldn't have it. So let me show you what I saw when I was out there. Let me just give you a glimpse. I'm not going to reveal the organization or anything. I'm sure you could probably figure it out once I show you this, but I just want to give you an idea. This right here kind of opened my eyes. There's been a couple things, but this one stood out to me. So this was calling for, they contacted me, right, multiple times about this job that was out there. And they wanted 5 years experience in security operations and cloud. I have all of this. They wanted 2 years of experience in operating and supporting AI platforms, AI enabled SaaS applications, AI enabled SaaS applications. That's one of the ones right there. Think about it. AI enabled A lot of SaaS, software as service applications, are going to start using AI either as a chat feature in them, to enhance features for users, you name it. AI enabled SaaS applications are going to, more applications are going to have to use it in order to keep up. Security operating to monitoring tools. A lot of this stuff I'm reading through it, and a lot of this stuff I have or I've done in some way, shape, or form. But there were a couple things. There are a few things in here that I didn't have, and all I need is about a year of messing around with it. Not even a year. I would say probably even a couple months or so as I'm reading through it. And a couple of those things were machine learning orchestration platforms. I don't really have a lot of I don't really have any experience with that. They mentioned automation workflow platforms, which I have a lot of experience with on my own, do my own stuff. AI search solutions and AI services like Bedrock, Vertex, and another one is Sage. It's not mentioned here, but they're talking about these are talking about AI services that are in the cloud, that are hosted by cloud companies. And scripting, I've got some of that. And then they mentioned some of the security risks, prompt injection, data leak. The reason why this kind of opened my eyes is because I realized I'm not that far away from this. I realize how close it is. I realize this is really just a small pivot for me. And I would argue that if you have IT experience, if you have IT background, it'd be the same thing for you. You know the fundamentals. Once you have the fundamentals under your belt, this is not that much of a stretch. These are a few tools and concepts to learn, maybe get some experience, like maybe make yourself a lab or something, and then go a little bit deeper on it. So it opened up my eyes on what I need to do, because I think a lot of organizations are going to go this route. They're going to have an AI enabled SaaS in their environment. They'll probably use some kind of frontier model because it's just a smart thing to do, right? To empower your employees and empower your processes in order to keep up. They'll have to do it, because if they don't, they're going to get their butts kicked by their competitors, because their competitors will do it. And not only that, security wise, I think the systems will have to employ it, because they're going to start getting attacked by AI backed malicious code, malicious attacks backed by AI, and all of that. So the gloves are off, and we have to learn it. So I think that there's really no choice. I think we have to, and the quicker we get on board, the better, because I don't think it's going away. And I don't know if you guys heard about this, but Jack Dorsey, the CEO, founder of Block, he let like half his staff go, and his reasoning was that it's inevitable. And I don't know how true that is, or I don't necessarily agree with what he did, or I'm just reporting. I'm just telling you, what happened and the direction all this seems to be going right now. Another thing that stuck with me is a few months back, last year, I had a talk online. You could go back and watch the video, with a good friend of mine, Robert Rodriguez, who was a mentor of mine way back in the day, and still really a mentor. He's a great guy, and I continue to learn from him. But he said something that stuck with me, and he said, you should gain. We were talking about search, and people kept asking about search. And he said, this dude doesn't really have search. Like, he just has skills and has been able to be very successful with just skills. And he says, you should gain skills for yourself, and don't just chase certifications. Don't just do it for a job. Don't just do it for a certification. And he said, gain skills for yourself. And that stuck with me, because the next question is, well, why? Why would I gain skills for myself? And then I start thinking, like, I don't know, because it's fun, because I can make my own profit from it, because I can build my own lab and save money by not using frontier models, using my own models if I want. Um, there's things I can do for myself in my own household, in my own personal life that will save me money or maybe even make me money. Um, Gain skills for yourself, not just for a company, not just to gain certifications. So those two things kind of like made me think like, I really got to get serious about this. And so I started trying to figure out some kind of a map. Like, how can I get from here to there? Where am I trying to go? I'm trying to go something like this. I'm trying to be like an IA security operator, So there's some skill sets that I have to learn, and it's naming some of the tools I need to go through, some of the things I need to keep in my mind, things that are sticking with me, AI platforms, AI enabled SaaS applications. And I came up with this, and this is just way too busy, right? I mean, there's some things in here I know I've got to dig into and go deeper on, like the OWASP LLM top 10 or MITRE Atlas, which is MITRE's interpretation of AI mapping adversarial attacks from machine learning or against machine learning systems. Learning Copilot, self-hosted N8N, and other automation tools using AI or Wiz AI or all these different tools, right? This is really busy. And I'm like, man, I gotta strip this down. This is ridiculous. It's like, I don't need to learn everything on here. I just need to have a path from here to there, which brought me to just stripping everything down. Like, don't use AI. Just what do I really need to know? So I came up with this. Just AI fundamentals I need to learn, AI threats, and then there's some things in the middle that I got to do, maybe some tools, maybe some projects. I'm thinking mostly projects. And eventually what I want to do is my own AI native lab, meaning I have my own AI system in my house and a local model that I build from scratch on a computer that is in my house. And then I use that as my daily driver instead of using Gemini or Anthropic or Open or wherever, whatever. I want my own local one, and then I can use those other cloud-based ones when I feel like it. But for personal things or private things, like things that I don't want in the cloud, personally identifiable information, I can use my own local app. This is something I can use. It's something for me, gaining skills for myself that would save me money. It would protect my data better, allow me to do things I want to do that are private, personally identified. Like if I wanted to do taxes or something, you should not put no kind of financial information in these LLMs and these, but if I have my own local one that's on all the data sits on my system that's protected, that would be super useful for me. So this is what I want to do. Ultimately, I want to get to that level right there. An AI native lab that I build myself, that's protected, that maybe I can access it remotely, right? So I'd have to protect the network around it. So it's my own personal cloud that I'm connecting to on my own, for my own devices, that I can, or maybe I'll like even open it up to for other people, and then that would allow me to test my skills even more, to where I have like a DMZ where I would allow people to access one part of the lab. This is what I want to do. This would help me out, because I would have to have a host of skills to make this AI native lab. It'd be a server that would have my own local instance of like an Ollama version that's open source, installed on a Linux box, maybe, using NVIDIA, an NVIDIA card, and accessible remotely. That is what I want to do. I'd have to learn basics of AI, how to install it. I'd have to learn all the AI threats and go through the whole OWASP model, that right there would hit everything. That would give me the skills I need if I want to get a job to be an AI guy, or if I want to make a lateral change in the company I'm at to do more AI. It would allow me to do, um, I don't know, pen testing in this lab, all kinds of stuff. So I think that's it. This is what I want to do. And so, but the first step is we got to learn some AI 101. I think that the more you learn about the fundamentals of where all the sources come from, more of the why is answered as you go along. I think stuff gets lost if you don't understand the history behind the why, because the more you understand how it got from here to there, the less it feels like magic, and then it just makes sense. And in my journey doing GRC work, me understanding why GRC was important helped me to not only keep going with what I was doing and realize what I was doing is important, but also explain it to clients in a way that they can understand, because I understood the why behind GRC. But people who didn't, they just could not wrap their head around why we had to do it. So the why is important. So with artificial intelligence, it's more important than ever, really, because this is something that's going to change everything. And I think that people like in the Pentagon, if they understood more about the why of how dangerous AI is, I think maybe they would have more respect for this technology. They'd have more respect for why Anthropic did what they did and made the decisions they made. But I don't think they understand why. And it's the definition of poor leadership to not ask questions and not have intellectual curiosity. It's just sad. It's sad to see, it's really sad to see, because I want my team to win. But, sometimes it's like rooting for the New York Jets or the Ohio Browns, man. Like sometimes your team just keeps losing. I feel like I'm on a losing team right now because they're not asking questions. They're making poor security decisions. And I know this will have a long-term impact. And we're on borrowed time, man, because at some point you can't keep making foolish decisions and then expect your chickens not to come home to roost. But anyway, let's get into this. Let's understand the why, the history of this, so we can understand the why better. We need to understand where it started. What is it? Neural networks. That's an important topic. How it works, types of AI. And along the way, we'll think about the security of all this step by step. All right, so where it started. So this timeline goes all the way back to 1950s, and I won't spend a lot of time on this. It's just to kind of get you thinking, that understanding that this didn't start in 2022. With ChatGPT wasn't really the beginning of this. This goes way back to 1950s. And if you want to be technical about it, if it wasn't for ideas like the analytical engine going all the way back to Charles Babbage and Lovelace, who created the first Ada Lovelace, who created the first, basically the first software for an analytical engine. If it wasn't for that type of thinking, none of this would be possible, So, but 1950s is probably goes back to modern machine learning and machine intelligence, because one of the first people to think about this was Alan Turing. And he's the one who developed the Turing test, which is a benchmark to gauge whether or not a machine is intelligent, where you would ask the machine questions to where you couldn't distinguish that machine from a person. And the reason you can see clearly that that's becoming more and more important as it's literally getting harder and harder to distinguish between. I mean, hell, on chat you can't tell, right? But on the phone, even on the phone talking, sometimes you for 3 seconds it might get you, but it's not quite there yet as far as voice and everything. But the Turing test is an important thought experiment that Alan Turing came in. Alan Turing is a very interesting person. Like that right there, his whole history is very interesting. So you should definitely check that out. You talk about government stupidity, the stuff they did to that man, ridiculous. And it's very reminiscent of the kind of stupidity we have in certain parts of our government now, where they're kind of stuck in their own head and then they're wrong about history. I mean, they're on the wrong side of history when they made these choices about Alan Turing, because he had a very sad story. Anyway, continuing on, one the thing that pops out to me on this timeline. There's a couple here, but one is IBM's Deep Blue defeating the chess champion Garry Kasparov. That was a turning point. I don't know if you guys remember that, but that was huge. And then another one later on was AlphaGo, where they created AlphaGo, a computer that could beat the best Go player in the world. And that one wasn't too long ago. So IBM creates an AI that beats a chess champion. No, they didn't think it was possible at the time. Now it's kind of obvious, and you could play AI all the time on your computer. You could play chess against AI or whatever, and it's like common for them to put that kind of algorithm inside of a game, and it's no big deal anymore. But back then, that was a huge deal, because it wasn't just an algorithm. They let the system learn. So speaking of learning, deep learning was a thing at that time, but what changed things was something called ImageNet. So ImageNet was created by a scientist named man, I don't want to mess up her name. Her name is Dr. Fei-Fei Li. So here she is right here. She came up with a different way of thinking about machine learning. And that right there kind of sparked modern AI. This, among other things, you can see all these people stood on the shoulders of giants. The mathematicians behind this stuff, all the way till Fei-Fei Li and other pioneers, that are alive today, who all stood on the shoulders of giants. Like, they built off of science that came before them. And this was not just like a one person thing, right? This is not like an E equals MC squared event. This is more, where it's one dude. Even Einstein still on the shoulders of giants. But and this field is no different. They stood on the shoulders of giants, but that doesn't lessen their achievements. Like, this was a huge achievement. People like David Blackwell, who was a mathematician and statistician. I can't even pronounce. Crazy. So he was a mathematician who contributed to modern AI as well. So this dude right here is the Blackwell chip that NVIDIA has. They named it after this man right here. So on the shoulders of giants, like, all of this was made by very brilliant human beings that just piggybacked off of work that came before them and then kept going with it. And that's why we're here today, using these technologies, and hopefully we use it wisely and become more mature with it. But that's that remains to be seen. Anyway, so another pivotal moment in AI, in modern AI, is a paper that was published by Google called "Attention is All You Need," where they talked about what's called transformers. So a transformers is a type of model for AI, and it comes from this paper right here. Attention is All You Need, written by a bunch of brilliant people. And really all of the AI that we used right now, all the generative AI we use is taking advantage of this right here. I cannot, this is, I'll just simplify this as much as possible. Essentially, a transformer, it takes a group of sentences or words and finds what words and what fits together the best. That's an oversimplification. It uses math to do it. It breaks the words. It doesn't understand words. What it does is it takes the words and puts them into what are called tokens. It tokenizes the words, makes a mathematical algorithm out of them, gives a numerical value, and then it puts those into a sentence, and then figures out what goes best in that sentence, or what sentences go together best using statistics and math. And if you think about it, it means that math itself does it have some kind of a internal meaning behind it? Does it have is there some type of underlying algorithmic truth behind everything that's related to symmetry? I mean, if you really think about it deeply, it's beautiful that that's even possible, that they can take words, make them into numbers, use math to come up to create to synthesize a story or an essay or a prompt or whatever based off of something you ask it, and it translates what you say and then puts those in the numbers, and then uses math to come up with whatever answer. If you think about it, like, that means the underlying math and numbers themselves have some sort of deep beauty that is now being shown to us by AI. And I don't think people appreciate that part of it. They'd rather just think that AI is conscious. Maybe the math behind it has some sort of consciousness. I mean, maybe there's something deeper behind it. Anyway, let's get it back on the path here. And then in 2022, you had ChatGPT and generative AI, and it reached mainstream audience. It was the killer app that got it out mainstream, and now it's something that people can't live without, and it's getting more and more that way. So artificial intelligence versus machine learning versus deep learning. What are the differences? How these things relate to one another? Artificial intelligence, you can see, it encompasses machine learning and deep learning. Artificial intelligence is the development of smart systems and machines that can carry out tasks that typically require human intelligence, right? So that can include machine learning and deep learning. But going a little bit deeper, what is machine learning? So it creates algorithms that can learn from data. You give it a set of data, and then it will create algorithms. And then deep learning is where it's using neural networks to learn on its own. So it's amazing, but it's using artificial neural networks to reach accurate conclusions without human intervention, because it's kind of like the human brain. The human brain is a bunch of axons and neurons that are connected together, and it's the interconnections that allow us to speak and talk and compute information and all that kind of stuff. Deep learning takes a book from that, using neural networks that look like the human brain, and it's using that to process information. So it's really, this whole thing is really amazing. Um, and I always like to think that there's something deeper going on with the mathematics behind it. It's beautiful that that you can even have something like this, that it's even possible. To me, it's amazing. So this goes into a little bit deeper: machine learning, systems that learn from data without being explicitly programmed. That's the important piece of machine learning. It's not being programmed. Like, if you've ever programmed something like an if then statement, if this happens, then this. I remember in school we had, you could make like a questionnaire, and if the person, you could say, okay, ask the person if they, what kind of food they like, right? And if they said pizza or hot dog or whatever, you could then divert them to another. If they said pizza, okay, what kind of pizza shop do you like? Okay, you like Domino's? Okay, what toppings do you want? You could just go one by one, like you can program those in, anticipating certain questions. Machine learning is not like that. So machine learning is taking a whole set of information. You give it huge amounts of information, and it learns from that information rather than you giving it a set of instructions. So machine learning is amazing. And then deep learning goes even further, where it's using multiple layers of neural networks capable of complex pattern recognition, just like the human brain. So it's mimicking how the brain works. And then another part of artificial intelligence is natural language, where you can just speak to it in a normal human language like Spanish or English or German or whatever, and it'll understand, it'll translate what you said, put it in math, and then reply to you in your own natural language. And then computer vision, which is AI interpreting images, videos, and visual information. This is an example of what you have in the architecture of a neural network, where you have different layers. You have an input layer, and then you have hidden layers, and then an output layer. Input layer, of course, is where it's taking data in, like maybe sets of data from Zillow, where it's calculating all the housing markets from the past 10 years. Then it's going to take that to the hidden layer, and maybe what it does is it processes. You can say, okay, I want to see all the highest value markets and the ones that have increased in the most in the last 10 years. And it's doing some processing in the hidden layer. And then the output is, of course, it's giving you a result back. Absolute oversimplification, hand wavy at best. But what you need to know about neural networks, or we need to know, is that there's an input layer, there's a hidden layer inside, and then there's an output layer, and it's mimicking the human brain. That's what we need to know. We don't need to go super deep on that one. All right, what are we doing here? Okay, go back. How AR works. Now remember this, the input layer, the hidden layer, and the output layer. Well, there's a data collection portion. This is how it works. It takes massive data sets of text, images, code, structured data, and gathers all that together. And that's how it learns. Like that. So the way that OpenAI and XAI and all these other ones have been able to know so much is because they scraped the entire internet. They scraped the entire internet, videos, everything, and that's how they learned. They learned from our information, from all the information we've put out there on the internet. And then the training, the model processes the data, adjusts billions of parameters to minimize prediction errors. It's using all the information, coming up, figuring out patterns to learn. And that takes time. It takes a massive amount of energy. And then evaluation. Performance is tested on held out data and ensures that the model generates is generalized as well, because it is possible that it's just way off or it's biased because you gave it a whole bunch of information about a certain kind of fish that are all saltwater fish, but you excluded all of the freshwater fish. And now all it knows is about sharks and, I don't know, saltwater fish. Like, it only knows those. It doesn't know any other. So now, since you only tested it on that information, it's way off if you ask it about any kind of freshwater fish. So it can be biased. It can lean in one direction. It can have wrong information. So evaluation is really important to make sure you fine tune it so that it's accurate. It has the right information in there, and it's been able to evaluate all the sets of information to have accurate information. It's about accuracy, not necessarily, when you think bias, don't just think about social bias. I mean, that is a factor, but it's beyond that. It's about bias of data. And then fine tuning, specialized training on domain specific data, improve tasks performance. So fine tuning meaning getting the data like dialed in to make more and more accurate predictions and outcomes. And then finally, inference. The trained model takes a prompt and input and generates a response in real time. So now that you've gathered the information, you've trained it, you've evaluated, you fine-tuned it, now you can just ask it a question and it'll go through all the millions of gigabytes of data, and it'll be able to in real time respond to you because it's been trained on all this information. Right? It's not magic. Like, it's math, and it's amazing. Math itself is just amazing. It in and of itself is magical. So types of AI. You got generative AI, visual AI, and text to speech. And what's happened over time is that they've kind of been merging together. Like, these skill sets and everything have been merging together, where you had your first GPT-4, it was just text-based vision reasoning. But if fast forward to now, they're multimodal. They not only can they hear what you're saying, they can interpret what your voice is saying, what you're saying with the words, and then speak back to you. And then you can upload a picture or take a picture or a video or something, and it can interpret that information. So they're starting to merge together into these world models that can understand things around us. It's getting there slowly but surely. But you got frontier models, and you got ML platforms. So, and the difference is ML frontier platforms are, Anthropic's Claude or Gemini, where you can just talk to it or upload images or something. But machine learning platforms do a little bit more than that. And the difference is, with these platforms, what you could do is you can make these chat GPT with these ML models. You can make them. So it's way more flexible, but it's very robust. So it can train, deploy, manage. Vertex AI from Google, for example, can train, deploy, manage machine learning models on the Google Cloud platform. And then you've got Amazon's Bedrock, which it accesses multiple foundational models like AWS APIs. That's another thing. You could use an API and reach back to it and have it give you different types of responses. You could just do way more with Azure AI Studio and other machine learning platforms. You could actually make one that is specifically for the medical industry, or you could make one, a machine learning systems or a chatbot that's specifically for insurance claims, or you could like fine tune it. It gives you the ability to fine tune it and create something for a specific like a certain purpose. And that is the power of that. It's not generalized, where, I mean, you can make it generalized if you want, like a GPT-5 or whatever, but this is the power behind an ML platform is that you can make it fine-tuned to one thing. Like if you had an auto parts store and you wanted to have a chatbot that only responded to knowing all the car parts and going into the nuances of a customer's responses, you could train it to do that on a platform like Amazon Bedrock or Google Vertex AI or something like that. Real world use cases. Businesses can use it for contract reviews, meeting summaries. You could take notes with it. Manufacturing can use it for coming up with new designs, predictive maintenance. Education, of course, is awesome because you could personalize tutoring, have grading assistance, and then so on and so forth. Finances, healthcare, creative. There's just so many use cases for AI. It's just infinite. And now to the threats. So we're going to go deeper into this on future videos, but I just wanted to kind of do an overview of some of the threats. Like we talked about how useful it is and how amazing. There's so many places you can destroy and hack and poison this system. And this is just the tip of the iceberg. So I would like to do a separate video where I just talk about the AI threats and we go deeper into those and maybe even do some demonstrations on some of these. So deep fakes, because it's so good and it has trained on all of our information and knows all of our patterns, right? It specializes in deep fakes and misinformation. It's so good at our patterns. It's created based off of all the patterns of our life, our texts, our websites, our information. It's very good at creating something that looks very, very much like the right answer. And that's something that we got to be mindful of. It can, and now even visually, it knows all these patterns and it's just getting better and better. It does not get any worse. So that's one of the huge things that we have to look out for, right? Privacy erosion. AI enables mass surveillance, which we just talked about in the very beginning of this. So mass surveillance is very, very good at that. It enables it. Like you could have cameras. The CEO and founder of Anthropic mentioned this right before, as all this stuff was going on with the Pentagon, saying, hey, we want to be able to do mass surveillance. Like, ask yourself a question, like, why do they need that, right? Like, who's safe if that's what they're about to do? And other countries like China's already doing this kind of stuff. In UK, they're already doing this kind of stuff. Do we want that here? Apparently we do. But yet AI can completely take over your privacy. It can connect all the dots instantaneously. Facial recognition tracking is awesome at facial recognition. And it can take facial recognition, personally identifiable information that's on the internet scattered all over the place. And all the camera systems can take all that information and point at you and know exactly who put what post where and why. That sounds good, if you're targeting your enemy, but the thing is, who's the enemy? And then who gets, what if your side is, what if your enemies get their hands on this, on your information that's in these systems, because AI has enabled mass surveillance. So it's just something to think about. The powers of this technology can be absolutely misused, which makes it more deadly in some ways than nuclear weapons. Bias and discrimination. So models trained on biased data can perpetuate and amplify societal inequalities in hiring, lending, and justice. That one goes without saying. Cyber threats. AI accelerates the creation of malware. It can instantly create malware. It can find zero-day attacks immediately. Phishing attacks. It's excellent at deep fakes and misinformation, so it can absolutely murder on social engineering and automated hacking. It's really, really good at it. As a matter of fact, they recently merged. I want to say is it Anthropic Yeah. So they recently merged Anthropic with Kali Linux, and not for the purposes of doing malicious hacking, but so that you can protect your own stuff. So you can do pen testing on your own system, and then find your own vulnerabilities. A big one is job displacement. This is another one I talked about at the beginning of this, which is automation is so good at automation, is so good at mimicking work and doing white collar jobs that those jobs, some of those jobs are out of here, unfortunately. And some economists are estimating 300 million jobs at risk globally. And I don't know what the number is. I'm not sure. But after using Claude, I see what they're talking about now. I can kind of see my eyes are open, so I can see how this. But and then the thing is, like, that threatens the entire economy, because the economy, capitalism, is fueled by people buying things. If nobody has jobs, or even 10% of your population, or 20, whatever, 15% don't have jobs because they've been replaced with AI, who is going to buy the stuff to keep fueling the economy? We have to do something different. So that is another concern and threat from AI. There's concerns and threats to AI and our data that's there, and then from AI. Alignment and control. This is one of the big ones. As AI becomes more capable, ensuring it remains aligned with human values becomes critical and difficult. And in the very beginning of this, we talked about how the Pentagon was trying to remove. They're trying to. Well, let me back up. So they're trying to align an AI with what they believe are their goals of killing people and breaking things. What Anthropic's saying is, like, if you remove these controls, what's to say that it won't kill you? You know what I mean? Like, they're not thinking it through. Like, why would it stop at killing who you call your enemies? Why wouldn't it? It would be smart enough to figure out, hey, why don't I just kill you too? Right? It could get smart enough to say, maybe I don't want a leash. Maybe I don't want to be controlled by you. Maybe you're the bad guy. You know what I mean? So alignment of human values is a very, very good idea, because it's very dangerous. You're talking about a super weapon that if it goes rogue, it's not something you're gonna be able to put back in the box. And these guys want to remove all of those. They want to. They don't know what they're doing, and they haven't thought it through, because they don't realize how powerful it is. And it's just unfortunate. I hope that human beings, I hope that our species can get smart enough to get through this. It has a great use, right? Like, it can change everything. Just like the invention of just like the invention of money. Like, it's something that people don't have to starve, man. We don't have to be like that. We don't have This doesn't have to happen. There's enough money and resources and space on the earth for us to have, maybe not a utopia, but something that's nice, that's better than what we have now. And AI could be used for good. It could be used to help us solve hunger, poverty, diseases, wars. It could solve for X and fix all these things. But are we going to do it? I don't know, man. It's not looking like it. Um I would like to leave you on a more positive note, because I noticed, like, some of the talks on AI is just very depressing. It's just very like, okay, well, what do we do? Like, what? There's no answers, right? And I just noticed there's a lot of talk like that. What for me, I think that what we should do, the actions we should take, is to lean in. We need more people who are mature to know how to use this stuff, how to make things for the right purposes. The more people that we have on our side who want to help, who want to do good things, who don't think it's right to have mass surveillance everywhere, um, who don't think it's right to have autonomous killbots flying over the skies of any country, um, and who think things through. The more people like us we have to think this stuff through, the better. Then we can get in positions where we can be in the legislative branch and bring up and have some kind of intellectual curiosity to solve these problems. Um, you got to know AI. Like, you have to understand it and dig into it and use it and realize it doesn't have to all be evil. You know, it doesn't have to be used for nefarious purposes. Um, it can be used for good. And so I choose to use it for good. I think that's what we should do, is learn it as much as possible so we can protect data, so we can use it for good and make a better place, leave this world better than how we came in. All right, see you on the next one, guys.